Ratios and proportions. So the goal here is to learn how to connect ratios, proportions, and fractions together. So let's start off here with the first definition. So a ratio is a comparison of two numbers with the same units. So example, well, let's imagine we have a class here. So in a class with 28 students. Okay, let's say we have 16 boys and 12 girls. So 16 plus 12 is 28. Okay, so if I were to express this as a ratio, I could say we have 16 boys to 12 girls. And I'm using a colon here to express this as a ratio, 16 to 12. Okay, and if I were to reduce this in lowest terms, I can divide each number by 4, and this becomes 4 to 3. So we read it as 4 to 3, or in this case, every 4 boys to 3 girls. Okay, so here this would be I would read this as every 4 boys, we have 3 girls. Okay, so this is how we express a ratio. It's just a very simple concept. Okay, so you always compare two numbers with the same units. In this case, we're comparing people. Okay, you can't say compare other things unless they're in the same units. Okay, so let's write the following in simplest ratio form. Remember, they must be in the same units. So 8 red Smarties to 6 blue Smarties. So simply put, I can say 8 to 6. So 8 double dot 6. Okay, and if you make sure you reduce this in lowest terms. So if I divide 8 by 2 and I divide 6 by 2, 8 divided by 2 is 4, 6 divided by 2 is 3. So I can rewrite the ratio as 4 to 3. Okay, let's go to B. So 3 years to 21 months. Well, these are now different units, years and months. So I'm going to keep 21 months. I'm going to convert the years to months. So if you recognize that there are 12 months in a year, then 3 years would be 12, 24, 36 months. So 36 months to 21 months. That would be my ratio. Okay, these are now the same units. If I do put this in lowest terms, I can divide each number by 3. So 36 divided by 3 gives me 12. And 21 divided by 3 gives me 7. So my ratio in reduced form is 12 to 7. Okay. Let's look at C. So 90 minutes to 2 hours. Well, I can express that in terms of minutes. So convert the hours to minutes. So 2 hours would equal, if there's 60 minutes in an hour, this would be 120 minutes. So my ratio, I would express the ratio as 90 to 120. Okay, and if I reduce this in reduced form, this would be the same as 3 to 4. Okay, what about D? 140 centimeters to 1.5 meters. So 1.5 meters, I can express that into centimeters by multiplying 1.5 times 100. So 1.5 times 100 equals 150 centimeters. So my ratio would be 140 to 150. And I can reduce that into lowest terms by dividing by 10. So it would be 14 to 15. Okay, 18 days to 3 weeks. So 3 weeks. So if 1 week has 7 days, then 3 weeks would be 7 times 3, which is 21 days. So my ratio would be 18 days to 21 days. Okay, in reduced terms, if I divide both by 3, 18 divided by 3 is 6, 21 divided by 3 is 7. So my ratio in reduced form would be 6 to 7. And then 4 hours to 5,400 seconds. Well, this might take two steps to convert. So 4 hours multiplied by 60 minutes in every hour times 60 seconds in every minute. And let me just show you 4 hours here in the beginning. Okay, so what are the units that cancel out? So hours in the top cancels with hours in the bottom. Minutes in the bottom cancels with minutes in the top. So I know I'm right because I have seconds left over. So 4 times 60 is 14,400 seconds, and the ratio is 14,400 to 5,400. Okay, and if I reduce that into lowest terms, my lowest terms would be 24 to 9. Okay, number 2, express each ratio in simplest form. So 4 to 8, I can reduce that to 1 to 2 by dividing both numbers by 4. 5 to 10, if I both divide both numbers by 5, I can reduce that to 1 to 2. Generally speaking, what you want to do is try and divide both numbers by the smaller number so that your ratio could be 1. Okay, 1 to something, 1 to something. 4 to 8 to 2. Well, in this case, what happens if I divide each number by 2? Because 2 is the smallest number here. Well, 4 divided by 2 is 2. 8 divided by 2 is 4. And 2 divided by 2 is 1. Okay, and so there would be my reduced ratio. Make sure you keep the order, right? You don't want to mix up the order, especially when now there's 3 of them in here. And you can also continue the ratio with multiple colons, okay, and that's fine too. 100 and whoa, did I miss one here? Oh, okay, that was already done. All right, so number 3, write an equivalent ratio for each of the following. So 3 to 4, just write another ratio. You could double the numbers. So if I double the numbers, I'd have 6 to 8. What about 3 to 8? Well, 3 to 8 can be written as 6 to 16 if I doubled each number. It's still the equivalent ratio. 1, 3, and 6, same idea, just double the numbers. So 2, 6, and 12. Okay. And 2 to 3, I can double each of one of those. I get 4 to 6. These are equivalent ratios. Okay, what about proportions? So if one ratio is equal to another ratio, what you have to do is find something called the scale factor. Okay, just like in the previous examples, I doubled each of those ratios. So the doubling means the scale factor is 2. I multiplied each number by 2. What about here? Well, you have to look at what number would you multiply to get to 20, and that number would be 2 times 10. Okay, that would get me to 20. So the same scale factor would be applied to the other number in the ratio. So 5 times 10 would give me my value for x. So x is going to equal 50. Okay? What about the next one? 15 to 11 equals 150 to x. So 15 times what number gives me 150? Well, if I multiply by 10, I get 150. So that means x would be the result of taking 11 and multiplying it by 10. And 11 times 10 is 110. So x equals 110. Okay, what about the next one? So 6, if I'm looking for x and x in the first ratio, then I look at the second ratio. The second ratio is complete. So I take the 24 and I look at how do I get from 24 to 6? Well, I'm going to divide by 4. 24 divided by 4 gives me 6. So to get x, I have to take my 20 and then divide it by 4, and I'll get my value for x. So x equals 20 over 4, and so x equals 5. Okay. Let's look at the next one. So here, part D, x to 14 is equal to 3 to 7. So if these are equal, they have to have the same scale factor. So starting from the completed ratio, work backwards. So 7 to 14, I have to multiply by 2, which means to go from 3 to find x, I take my 3 and I multiply that by 2. So x is equal to 3 times 2, and so that is equal to 6. Okay. Next one, x to 25 and 9 to 5. So again, from the completed ratio, go backwards. 5 times what gives me 25? Or maybe you have to ask yourself if it divides, but I'm going from the smaller number to bigger one, so I have to multiply. So 5 times 5 gives me 25. which means I multiply the 9 by 5 to get me my value for x. So x is going to equal 9 times 5, which is 45. And then last one on this page, 3 to x is equal to 99 to 3. So the completed ratio, 99 to 33, I'm going to just take my 99. To find 3, what do I have to do? I can't multiply, I have to divide. So divide by what? Well, if I divide by 33, I'll get 3. Okay, so if I divide that by 33, then I have to divide this pair of numbers by 33. So 33 divided by 33 gives me x, and so x is equal to 1. Okay, let's do some applications. So the winner in a school election won by a ratio of 5 to 4. The losers received 576 votes. How many votes did the winners receive? So the winner won by 5 to 4 votes. So for every 5 votes he won, 4 votes he lost. So that's equal to the other ratio of the actual number of votes. So you have an X amount of votes that he won, that he received, and the loser received 576. So what is X? So you look at, what do I have to do to go from 4 to 576? Okay, so you have to take your calculator. It's a very simple procedure. Okay, so once you have your calculator, you punch in 576 divided by 4. So 5 divided by 4. Oops. 144. And if I took 144 and multiplied by 5, I will get 720. So 4 times 144 gives me 576. So that means 5 times 144 gives me x. So x is equal to 5 times 144, which is equal to 720. Okay, so let's go to my next question. How many votes were cast in total? Well, if your ratio is 720 to 576, to find the total number of votes, you add them both. The vote 720 votes for the winner plus the 576 votes for the loser. So therefore, the total is equal to 720 plus 576, and that is equal to 1,296 votes. Okay, number 2. The ratio of tickets sold for adults, students, and children was 12 to 8 to 3. Okay, so the adults was 12, students were 8, and children were 3. If 432 adult tickets were sold, how many students' tickets were sold? So I'm going to look at only the first two numbers in the ratio, 12 to 8, because 12 represents the number of adults and 8 number represents the number of students. And that ratio is going to equal to the number of tickets in total. So 432 adult tickets in total were sold, and I'm going to say X is the number of student tickets were sold. Okay, so to find this scale factor, I have to know what number do I take multiply by 12 to get to 432. So the scale factor, I'm going to write some other notation. SF is equal to 432 divided by 12. Okay, and once you know that scale factor, you can take that scale factor and multiply it with the 8 to get X. So X is equal to 432 divided by 12 times 8. And that number is going to be 288 tickets. Okay, so moving on. If tickets cost $1.75 for adults and $1.25 for students and 50 cents for children, how much money was collected? Okay, so the number, now let me just have a little technical. Okay, so the number of, the ratio we're going to look at is the number of adults to the number of children first, so 12 to 3. And the reason why I'm going to look at this ratio first is I have to know how many tickets were sold for the children. Okay, so this is going to be equal to the 432 adult tickets that were sold in total to the new variable. I'm going to use y. Y represents the number of children. Okay, and if we're to solve this ratio, well, the scale factor we already know is 432 divided by 12. Okay, and that scale factor, if I divide 432 by 12, it's 36. So the scale factor is equal to 36. So if I take 3 and I multiply it by 36, I'll get my y value. Okay, and the y value is, let me just take my calculator here. So 36 times 3 is equal to 108. So in total, y equals 108 children tickets. Okay, so how much money was raised in total? So in total, the total amount is equal to, it's $1.75 for the adult tickets, and I sold 432 in total. I have to multiply them. Then I'm going to add the student tickets. So in total, I had $1.25 for the students times a total of 288 tickets sold, plus the children's tickets, which are 50 cents each times 108 of them that were sold. Okay, and then so in total, since I'm out of space, I'm just going to write the equal sign here. In total, they have raised $1,170. Okay, so moving on. Next question. So the ratio between red, green, and orange jelly beans in a jar is 5 to 3 to 2. If there are 100 red jelly beans, how many green and orange jelly beans are there? Okay, so red, green, and orange. So sometimes it helps to just use these letters. The red, green, and orange are 5 to 3 to 2. Okay, so if there are, in total, there are 10 in total. So 5 plus 3 plus 2 is 10 parts in total. So 5 parts red, and 5 parts would be green and orange. So 5 parts are red, and 5 parts are green plus orange. So I'm not going to separate them to green and orange, so 3 and 2. I'm just going to combine them and say 5 parts green and orange. So they're equal parts red, equal parts green and orange. So therefore, if you have 100 red jelly beans, then you must have 100 green plus orange. Okay, because the ratio is 5 red to 5 green plus orange. So if it's 100 red, then it's 100 green plus orange. Okay, let's look at number 4. A mystery liquid contains chlorine and mercury in the ratio of 6 to 25 by volume. If the solution contains 925 milliliters of mercury, how much chlorine is present? So 6 to 25 is my ratio, and that's equal to the actual volume. So X to 925 milliliters. So we solve for X. Okay, so simply put, you can also rearrange this as a fraction. So 6 over 25 is equal to x over 925. And so x simply would be 6 over 25 multiplied by 925. And then therefore x is equal to 222. Okay. However, if you're still comfortable with the way I'm showing you with the ratios, I'll show you that to you as well. So here we're gonna just show, okay, what number do I have to multiply to get from 25 to 925? So start from the completed ratio and find that scale factor. Okay, so to find that scale factor, I'm going to take 925 and then divide it by 25. And that's going to be 37. So that scale factor is multiplying 25 by 37. So if I take a 6 and I multiply it by 37, I'll also get my answer for x. So if I take 6 and multiply by 37, I'll say x is equal to 6 times 37, and so x is equal to 222. Oh, excuse me. Number 5. So a mystery supermetal alloy contains gold and silver in the ratio of 21 to 2 by mass. So 21 would be kilograms of gold, 2 kilograms of silver, that kind of thing. Here are grams. So if a sample of 690 grams of the supermetal alloy is taken, how much of each metal is present? Okay, so 690 grams in total of the whole combined thing. Okay, and we know that the total parts is equal to, there's 21 parts silver and gold and 2 parts silver. If I add those two together, in total we have 23 parts in total. Okay, so if we have 690 grams and I divide that by 23 parts, then I'm going to have approximately 30 grams per part. Okay, so that means if I look at gold, okay, I have gold, and that's going to equal, if I have 30 grams of per part, and I have 21 parts, then I should have 630 grams of gold. And what about silver? Well, for silver, again, if it's 30 grams per part, I'm going to say 30 times how many parts of silver? Well, I have 2 parts of silver, and that's 60 grams. Okay, so my ratio of gold to silver is 630 grams of gold and 60 grams of silver. If a sample contains 483 grams of silver, what is the mass of the sample? Okay, so the first one way you can do this is just to show, okay, if I have 21 parts to 2 parts, that ratio is equal to the actual amount of the alloys, so X amount of gold to 483 grams of silver, solve for X. Okay, and if you follow the same process, find the scale factor. So the scale factor here could be found by looking at 483 divided by 21. So 483 divided by 21 is equal to 23. So scale factor is equal to 23. So then I multiply 21 times 23 to get 483. So that means I multiply 2 times 23 to get x. Okay, so x is equal to 2 times 23, which is equal to, whoops, I made a slight error here. Let me just backtrack for a second. I just pointed to the wrong numbers. Okay, so mistakes like this can happen. Make sure you follow this correct order. So 21 and x go together, and 2 and 483 go together. Okay, so the scale factor, if I divide 483 and 2, well, it's not a nice number. It's going to be a decimal, and that's okay too. So 483 divided by 2 is 241.5. Okay, and so if I take 241.5 and multiply it by 2, I get 483. So this is my scale factor, 241.5. So again, I have to take my 21 and multiply that by the scale factor, 241.5, and I'll get my value for x. Okay, and if I do that, I'll get a huge value for x, 5,071.5. So let me just write that down here. So x equals 5,071.5. Okay, so what's the mass of the sphere, or the sample, I mean? So the total mass is equal to the 483 grams we were given of silver, plus the 5,071.5 grams of gold, and together they add up to 5,554.5